So Alberto, as our chief engineer and someone responsible for architecture of our high frequency systems, you are really leading our development of NFC charging. Can you just basically break down what is NFC charging?
So NFC charging is the technology to leverage the NFC channel and that infrastructure and transfer power as well as data.
Okay.
So right now, NFC is well adopted around the world as the go-to technology for tag detection.
It's like used in Apple Pay, Google Pay. I
Credit
think it's in
cards.
over credit cards. I think it's in over 2.5 billion devices annually. So it's really popular.
So it's magnetic coupling. You're inducing a current into a coil at 13.56 megahertz,
Okay.
and you're receiving a little bit of power to transfer the data.
Like how much power?
Just milliwatts of power.
Okay, so in a normal payment scenario, or we're using a credit card to pay for something, it's transferring a couple milliwatts of power in order to give enough energy to the credit card to send back your personal data to complete the payment.
Right.
Okay.
Yeah. Maximum milliwatts. On a lot of cases, just microwatts.
Okay.
Really low enough power. So if we start talking not on milliwatts of power, but a couple of hundreds of milliwatts, then you're starting to not only transfer the data, but then you may have enough power availability to start charging the battery.
Are there any examples of products in the world today using NFC wireless power? And what are the limits right now on power level and data rates?
There's the NFC WLC standard that just came out last year, guarantees up to 500 milliwatts of power with a data rate of 106 kilobits per second.
Okay.
There's already a couple products out there. I think that one-way glasses.
Yeah, I think they're called Gentle Monster.
Okay.
You have some AR glasses, because it makes sense to put wireless charging on AR glasses.
Right.
They're going to get wet, so you don't want connectors. You don't want them to be brittle. It's kind of weird to bring a cord to the glasses. So I think that that's a good one. So what else is out there?
I think it's the Microsoft Stylus.
Yep.
Both of them are kind of relatively low power. Well, from the wireless power perspective,
Yep.
hundreds of, I think it's 100 milliwatts
Okay.
on both of them.
Okay.
So kind of on the lower spectrum of the power availability of the WLC standard that
Yep.
NFC has displayed, but it's definitely a great start
Yep.
for the standard.
Yep. I feel like they're limited. It's not like they wouldn't want to use more power. I think that they were trying to reduce the power to a usable level, but also a level that made it easier for them to pass their thermal requirements and also potentially some of their EMI requirements. So whereas the standard currently can go up to 500 milliwatts, if they're only using 100 to 200 milliwatts, it was probably a design concession to get first products out into the market. But I'm thinking about whole categories of devices where 500 milliwatts is, maybe interesting to think about, like earbuds, some wearable devices. But most devices that we use regularly, that we wear, that we carry with us, it doesn't really start to get interesting until you're into like the 1 watt power range, especially when you think about wearables. So right now, you said the NFC Forum has a WLC standard for 500 milliwatts and 106 kilobytes per second.
Yeah.
But does the story stop there, or why don't you talk about what we've developed here and where we are pushing the industry standard?
Yeah. So we definitely saw that need, as you said, that 500 milliwatts may not cut it to satisfy most of the wearable power-hungry devices. So we have been working and we have developed a technology that can go up to 3 watts of power and up to 848 kilobits per second.
Wow. So 6 times more power and 8 times more data rate.
That's right.
Okay.
Yeah. And the 3 watts was, after you realizing 3 watts was gonna be able to accommodate most of the wearable devices out there and their power needs. And 848 is because we really wanted to give freedom to the OEMs and the ODMs to have a communication channel rather without restrictions, right? So if you want to have a firmware update, we wanted that firmware update to be done at a reasonable time. We didn't want the user, because at the end it would be the user that would experience a long time without using the device because of a firmware update. So this communication of 848 can really guarantee a better user experience and more freedom for for the designers of the product.
Awesome. So we're really pushing that standard forward in a pretty substantial way with multitudes more power, multiples more data rate. Let's get a little geeky right now, and let's just talk about, we call this booster technology, right? So what are the main elements of booster technology? Why are we able to do 6 times the power and 8 times the data rate when no one else can do that today?
In order to do that, we need to break down kind of like what an NFC system is composed of.
Sure.
So you first start with a transmitter. This transmitter is typically now NFC, widely adopted technology, is usually just an IC. So an IC does it all. From a transmitter side, you have an IC that does the conversion of DC to AC to 13.6 megahertz. It has some amplifiers there. It has the modulation module to modulate the data going in. And then you have the demodulation module. Sure. These devices were designed to kind of transmit up to 1 watt of power because that, the architecture was designed for just transmitting data. Transmitting data, you don't need more than that. But if you want to transfer power, you cannot transfer power with that IC. So what we call booster is that we have an amplifier in parallel with this IC, so that that amplifier, that external amplifier, is handling that power while still taking advantage of the modulation and demodulation modules of the IC.
But what is it about the power amplifier, whether it is embedded or discrete? What is it about the power amplifier that allows for boosted power versus the power amplifiers that otherwise exist?
Having an amplifier, to summarize, that can transfer power and data efficiently. Those are the 2 key metrics for a good amplifier for NFC.
All right, you walked through various blocks of the system. You hit on the front end of the system. What else do we have that's required to do this high data rate, high power rate?
So now we talk a lot about the transmitter. The receiver, that's another story. Normal NFC devices, they are expecting a relatively lower magnetic field. If you're just transferring data, you don't expect to have a strong magnetic field relatively.
Sure.
But now you're expecting to receive power and data. So the ICs that are designed for NFC, they're not rated for this type of strong magnetic fields. So being able to have a device that is able to handle the data despite the high power, that's a big challenge. And then being efficient on the regulation and on the conversion of AC to DC.
Right.
That's the other challenge. So in a sense, it's almost like the same requirements for that transmitter, but they're kind of also completely different, because now you need to be able to handle that receive power, and on the data perspective, you need to be able to demodulate that message well enough to understand it despite the higher voltage and despite the higher field that is being received.
All right, so it's almost identical, but it's also completely different.
Yeah.
Got it, really easy. Okay, so we didn't even get into some of the controls and the software elements that are required for this. And we'll leave that for another time, but suffice to say, NFC technology is in, billions of devices. The opportunity to make small form factor wireless power and data work is there. It's limited today to about 500 milliwatts, but we know that there's a record-setting product coming to the market here in the fall, another one coming after that in the winter, and we're going to see a huge trend now towards these very small 1 watt, 2 watt, 3 watt products that can do hundreds of kilobytes per second. And I think that's going to really open up opportunities for devices that can benefit from smaller batteries because they can charge more often, maybe elimination of batteries altogether, certainly elimination of the physical connectors. So I think it provides a lot of opportunity to product designers and to just business units.